And so these are the sort of built-in things in our library that you can add to your apps. We also have a new command, Sophisticole filter, which is it's a kind of a least squares optimization, and it's also called least square smoothing, polynomial smoothing filter, and so on. And this is a new command that we have, and I thought I'd mention it just so that you can see some of the new work we had put in 2023. There have also been improvements to FFT and inverse FFT. They support padding and truncation. So I won't go through all the improvements, but if you go to the help page, you can take a look at all the new things that we've added to this package. And just to remind you, if you want to see what's new in all our releases, just type in updates in the help browser, and then you get to see what's new in every release. And if you click on it, you can go through the different topics, and that way you make sure you don't miss anything that's new and important that you can take advantage of. The other package that we've been really spending a lot of time improving is called thermophysical data. And this package, it basically contains functions for computing thermophysical, thermodynamic, thermochemical properties, and it relies heavily on the CoolProp database. There are some sub-packages here. The thermophysical data package is the top level one. Then we have a CoolProp sub-package. Now we have a chemical sub-package and an atmosphere sub-package. And just an example of an application that is in our examples and applications index here in Maple. This is one of the applications that was built to use to show off the chemicals sub-package. And so, for example, you can access different physical properties here and use them in calculations and get nice visualizations. For those of you who teach chemistry or chemical engineering, we have a Maple Quantum Chemistry Toolbox that was introduced in 2019. Now, this is an add-on product, so it doesn't come with Maple. You have to pay extra for it. But for people who teach or do research in this area, it's probably quite worthwhile. Instead of describing it, I'll just point you to David Mazziotti, one of the authors, and he posted a description of the new package when it was introduced in 2019. I'm showing this to you not just to show you a quick glance at this toolbox, but also to remind you that we have our Maple Primes forum. It's been around for, maybe almost 20 years now, I think. And so there's a big archive of questions and answers in it, and postings from MapleSoft staff, and contributions from our users. So if you have a question about Maple and you can't find the answer in the help pages, then this is a good place to look. So don't forget our Maple Primes forum here. All right, now let's go back to Maple. Anyways, so this toolbox has been getting additions in the last few years. David Mazziotti has been continuing to improve it, and with his colleagues. And some of the newer additions include prepared lessons that can be used in chemistry and physics courses, and apparently from high school all the way to the graduate level. I already mentioned this in the last talk, so I won't repeat it, but just wanted to include it for completeness that there is new physics courseware support for teaching mechanics with Maple's physics package. Okay. All right, so those are the new and improved packages. I'll talk briefly about a few faster computation. I know that the focus for you is really on creating apps that you can use in classrooms. That's the focus of this workshop. But just thought you might want to know some of the performance improvements for those of you, especially who are longtime users, and you may have been complaining about certain parts being too slow. Hopefully this will give you an idea of some of the progress we're making in different areas. So I wanted to remind you when people ask me why should I use Maple compared to other mathematics packages, and to me one of the key advantages is all the symbolic computation functionality, the exact arithmetic, the ability to work with arbitrary precision, changing digits to get more precision. But at the same time, you really have access to a large number of numeric libraries. And the numeric libraries, these external libraries, are used within Maple to give you fast computation for linear algebra, optimization, signal processing, a solution of differential equations, statistics, and so on. So to us, we started off as a symbolic computation solver, a computer algebra system, but numerics are just as important to our product. So we're continually trying to improve that, and in Maple 2023, especially, there have been improvements to initializing hardware float matrices and vectors and array data structures. That's the biggest thing. But you can look at the help page, the updates page, for performance improvements to get an idea of all the other improvements that have gone in for performance. I also want to highlight units because this is something that a lot of people like and use. Now, we have a units package for managing units and dimensions. I don't know how many people in this audience have used units before or use it extensively in their work. If you've not used it, there's a great help page. All you have to do is type in units to reach this help page. And it gives an overview of how to work with units in Maple, how to shortcuts for entering them. We have different environments where there are some differences in the computation that's used that you can choose. And also some information about using different measurement systems and converting units. So if you've not used units much before, I encourage you to try it out. And basically, the aspect of it that's relevant to Maple 2023 is that we've made significant improvements in the performance, and in particular the unit simple sub package. So everything should just run faster and more smoothly. We've had other improvements too. I mentioned last time the improvements to adaptive plotting. That has made finding discontinuities much more efficient. And so we saw some examples of that yesterday, but also importing data from a file, solving systems of linear equations with rational coefficients, and so on. So again, I refer you to the help page to find out all the details in terms of performance. If you last used an older version of Maple from a few years back, you may be pleasantly surprised by how much smoother many parts of the library works now. All right. Again, if you have any questions, please can pass them to Dr. Normie or put it in the chat. All right, I'm going to spend some time talking about different applications. So in this talk, I'm not really, as before, I'm not really going to show you how to create these applications, because that's part of the work, the hands-on workshops you'll be doing. But I wanted to show you a variety of applications so that you can be inspired by them, get some ideas. Also, to tell you the truth, whenever I have to create a new application, I rarely create it from scratch. Instead, I find an application that I like, where the functionality is similar to what I want, and then I either just use it as is with some modifications, or I copy and paste different components from different applications and put them together. So I'm going to show you the range of applications we have, so that you have some ideas to use when you start creating your own. I already showed you the Math Apps guide from last time, but I wanted to point out a couple of collections that you will find, that you may find interesting. So there's the Engineering and Applications one, where, let me just close this. And we have a number of interesting applications from different areas of engineering here. So I encourage you, after this lecture is over, to browse through these to see what you may find useful to you. We also have a lot more also in this collection for natural sciences that you may want to include in some of your engineering math courses. And we have astronomy, earth sciences, biological and chemical sciences, and of course a very good physics collection. So these are some of the examples. I'm going to pull one up so that you can see what it looks like. This one's a fairly elementary one. I thought I'd start off with something simple. This is a very simple app, but I think quite effective. There's only a single slider affecting the slope of the hill, but you can see how just moving the slope, you see the visualization update, and also the computation updates as well. And as I mentioned last time, if you want to view this, you have to click on this editable button, and then you can look at the startup code. And most of the code is all set up here. And you'll see actually there's really not a lot of code. In fact, a lot of the code is just for making the plot look as pretty as possible, doing the calculation. So this one is a fairly simple one to put together once you know a little bit of programming. And like I said, even if you don't know much Maple programming, you can still just copy and paste and make adjustments to different apps. For instance, if there's an app that you already like, but you don't like the text description, or you want to refer to your own notation or your own description of it, it's easy enough to take one of these, click the editable button, just replace the text with the text that you want, and then keep the rest of the application and save it as your own. So these are all very easy to modify. Let's see. But there are, apart from the math apps, there are other applications. We have a very large examples and applications index. And this is a huge collection of worksheets in all different areas. And since we have an engineering audience here, I'll show a few here in the science and engineering area. And what these are, not all of these documents are interactive applications like the math apps are. Some of them are overviews of Maple packages that give you some insight into how to use the package or the command in an effective way. Some of them are just demonstrations of different topics, and so let me show you one of them to see an example. So this one is filtering frequency domain noise, and it's one that uses the signal processing package. I'm not going to go through and explain what this does, but I wanted instead to point out some of the nice things in this application that you might want to use for your own content. So we have browsable data tables, so you can import data and put it into a data table and then be able to browse through it. We have the nice plots from the signal processing package, and of course use of all the different commands. One thing I like here, this by the way was created with our explore command, which has been around for a long time, and it makes the explore command, you basically just give it a command with a parameter and then give some options, and it will create an interactive app for you. So this whole thing was really created with this one command, where F was this procedure was defined ahead of time. And of course, you can also use the context panel to get the, sorry, it doesn't show up here because it's a bit of a mess. But if you enter a command that you want to explore and you use the context panel, the explore option will come up. Here we just called explore command, and it creates this. So what? Let me see if I can reduce the size of this so you can see it better here. Oops. Okay, there we go. So one thing I like about this is how, if you, whoops, it doesn't work. And the reason it doesn't work is because I didn't actually execute the code above it. So let me execute the code first. All right, and now the code is executed. And if I move the slider, it actually changes these two plots in sync. And as I mentioned, this was a very easy application to build. The hard part, of course, is just writing the code to do what you actually want to show. But then creating the app that explores the parameter is very, very easy, just one command. And so this is an example of one of our applications worksheets that you'll find in the index. So again, the examples and applications index, there's many of these added over the years. There is one other very good source of applications, and that's the Application Center. The Maple Application Center has been around for a very, very long time, almost since the beginning, although it's been changed in format at various times. But the Application Center is different from Maple itself in that it has applications from our own staff members and applications also submitted by users. So sometimes we have our own staff members say, oh, I want to try this new application, I want to show this new thing, but it didn't get into the release in time to be put in the help pages, so we just add it to the application center. Or maybe it's something that's small and useful, maybe not important to be featured in the product itself, but we wanted to share it because somebody could make use of it, so we submit it to the application center. And of course, our users, when they create content for their research or for their classes, they also submit it. And so here you can see applications from these are submitted from our MapleSoft users. There's a few here that are from our own staff members, and you can browse this and look at different products. We have applications for Maple, MapleFlow, and MapleSim here. And we have different collections for different topics, such as mechanical engineering or electrical and so on. So this is a great place to go to find applications. Now, yesterday I told you about 2 ways in which you can be part of the MapleSoft community and join us in sharing your ideas and your work and your enthusiasms. So one was the Maple Transactions Journal that we just started a couple years ago. The other is the MapleSoft Conference, and this third thing now is the Application Center. So I invite you not just to use the documents in the Application Center, but if you create something interesting of your own, please share it with us and let others benefit also from your own knowledge and creativity. All right. Okay, so and let me just show you one document that's from the Application Center, so you can see an example. This one was created by my colleague Samir Khan, and it shows basically an application with water flow using differential equations. You know, one of the great things about Maple is that you can create nice documents that also have live math in it. So in this one, this one is not like the other apps in which there are buttons to click and sliders to move, but it's still interactive in that you can change any of these parameter values to different ones, and then the worksheet, if you re-execute the worksheet, it will automatically update all these calculations. So and update the plot. So it is interactive in that sense. Okay. All right, let me just clean up here a little bit. All right, so those are the 3 different places where you can find applications for your own inspiration or to copy ideas from. Now let me talk about programming and connectivity. So this is a little bit more advanced, but I know that I'm sure some of you are experienced programmers. Some of you are probably experienced Maple programmers. I myself I've been doing Maple programming for over 20 years. In fact, my first 20 years at Maple, I had been doing almost nothing but programming, working on the Maple library, and it's only in the last couple years that I started working on Maple Learn content and doing more outreach things. I love programming in Maple. I love teaching people to program in Maple. Over the past few years, I've done a number of workshops on programming. So if there is an interest among any of you to get to do some workshops in programming, you can please speak to Dr. Simbus, and he will be able to probably arrange something, because I always like teaching people how to program in Maple. As I said before, programming is not something that you have to do to make great use of Maple, but it's just another tool that you can use to be able to do more and to have more options. So one thing that we've been really promoting the last few years and improving it is the code edit region, and this is a box. The way you insert it is you go to insert code edit region, and then this shows up. You can use the context panel to adjust. I always prefer to uncheck auto fit container and then to change the width and height to something I want, and it makes scrolling through it just easier also. So that's just a small preference on my part. Anyways, one of the nice things about code edit regions is there's automatic syntax checking, and so if you have incorrect syntax, it will show you some warnings. You can execute here. Let me just put the colon at the end to get the output out, and so it's a really good place to put your code. And now specifically in 2023, we have made some major improvements to code edit regions. Now, if you have a file with the extension .mpl, you can use the file open menu and read in that file, and it automatically puts your code into a code edit region so that you can edit it from there. You can also add 1D math expressions from the expression palette. So you can if you're in here, you can enter things from the expression palette directly. You can also do that with units. And of course, when you enter it, the 1D form shows up. So if you put that in, you get int, not the 2D, because code is written in text mode. So many of these there's even more improvements than this, and what you can do is look at the what's new, the updates, and coding tools will give you a description of everything that was improved for code edit regions. There's a few other significant things. One is Open Maple for Python. So a lot of people like programming in Python. It's a very popular language. It's especially popular, I find, at least in Canada, in high schools, because it's a language that's quite powerful, but also easy for first-time programmers to learn. And so we've improved our connectivity to Python. So Open Maple for Python's an interface so that you can access Maple algorithms and data structures from within Python. But it works the other way. You can actually have a Python code edit region. So if you open up if you create a code edit region and open up the context panel, you'll see that you can have Maple or Python as the language, and then you can actually execute this also in within Maple. So there's very good connectivity. Some We had some major changes from 2022 also. So the Python the code edit regions from 2023, but in 2022 we added the Jupyter package, where you can create a Jupyter notebook that's suitable for use with the Maple kernel. For Jupyter from a Maple help page or a worksheet or an expression. So and includes tools for customizing the way Maple output is displayed within Jupyter. So this is a package that we just introduced last release, and I'm sure there's ongoing work on it since a number of people have asked for this. It seems to be some interest. One other thing that I want to mention is the deep learning package. So this was introduced, I think, in 2018 or 2019, and it's a collection of tools for machine learning based on Google TensorFlow, and it's been increasing in popularity. And because of that, we've made a number of different improvements. And you can look at connectivity in Maple 2022 to see all the updates, the specific updates related to that. So these are some of the programming and connectivity highlights of Maple 2023. You can try all these out, and as I mentioned, if there's interest in learning more about programming, we have all sorts of resources for that. For a number of years, when we first introduced our natural math interface, a lot of people loved it because they didn't have to do any programming, they didn't have to know commands, and I can really see the advantages of that. But now some people are saying, okay, I've used the natural math interface, it's great, but now I want to do more. I want to have customized apps that do something that has not been done before. I want to build a package related to my own research or to my own teaching, and so it's good to learn all these tools. It just gives you more options. So I've covered most of the things that I wanted to talk about here. So I think I took a little less time that I had intended. So I hope I didn't go through everything a little bit too fast. But a lot of these are really, I can show you what's there, but you will probably benefit the most by just going through it yourself, browsing through the different apps, browsing through the updates pages to see what new things are there, looking through all our packages and trying out the commands. And so that's, I think I've come to the end of the topics, but I want to leave some time for questions or even discussion. Be interested to know what sort of things that you've been doing in your workshops and what else we can do at our head office to support you. Okay.
Okay, thank you so much, Dr. Paulina. So in our workshop, we have our trainer is Associate Professor Rahizat Talib. Okay, so he trained us on how to use maybe the background of the participants. We are not that well versed in Maple. So our training includes using some command, using the components such as a slider, and then button, and also yesterday we discussed on how to use Explore.
Yes,
Okay, to
great.
automatically generate map apps. Okay, very interesting. Okay, because most of us are educators. Okay, so that one is really helpful. Okay, to assist us in preparing our content for teaching and learning. Okay, and then just now, sorry, I can see that we can integrate Python and also Jupyter in Maple. So that is very interesting because that one is a very useful knowledge for to compete in industry.
Yes.
Okay.
Yeah, that's
Mhm.
yeah, that's great. And I'm glad that you've been spending time on Explore. Um, I didn't spend enough time probably in my own presentation showing it because Explore has been around for a long time, and so I didn't want to go over things that most of you might already have used. But Explore is really a wonderful command that people don't realize the scope of Explore. They might try to explore some expressions or a very simple plot, but really you can put any Maple command in it as long as there is one or more parameters that are changeable. You could put anything in it and then explore it. So I hope that all of you have been trying out the scope. So you could take a command from the signal processing package as I showed in one of the applications. You can use any of the packages. You can write a procedure to string a whole bunch of different commands together and then explore that. Oh, that's great. Are there any questions from the audience, or any topics you want me to say a little bit more about?
Dr. Paulina, if some of the participants are interested to learn about Maple, do you have any, for example, any short course in maybe Coursera, for example, so that they can they can enroll in the course?
Yes, so we have, I think on the Maple, this is something Dr. Asim will be able to help with. Probably he knows all the best resources for this, but we have webinars and we have workshops, and I think there's a mailing list that you can join and you get announcements of upcoming ones. So I often do programming workshops a few times a year, and you can sign up for them. But there's also workshops on more just the basics of Maple, or because we have a lot of people who have only used Maple a little bit and want to learn more. Then we also have people who are more experienced and want to go deeper in programming. So we have a variety of courses. The other thing I would be interested in is if there are specific courses that you want us to prepare, if there are specific workshops that you would find useful, you should let us know those ideas, because we're always trying to come up with good tutorials, videos, workshops, webinars on subjects that would be of interest to our users.
I just wanted to add to it, Paulina. Thank you very much. Dr. Nomi, you're well aware that there's a remote learning resources that we have placed in our maplesoft.com. That was the addition a couple of years ago. Those remote learning resources from Maplesoft has a lot of recorded material that the participants can use. Maybe Professor Rahedzab can actually highlight that later in the day. It is on maplesoft.com, and you can go into the support and resources. and you'll see, content hubs. Under those content hubs, you'll see Teacher Resource Center, which has been around for many years, Student Help Center, and the Remote Learning Resources, which has some good resources that the team has put together. So that's a good place to look at. The other thing that we always highlight in our regular workshops is the product documentation area on the website. That product documentation area has got some good starter guides for some of the areas of programming, which Dr. Paulina was mentioning earlier. So those are really good sources for someone who's trying to get started with Maple, or even for advanced users. But again, as you highlighted, that if there's a need for Coursera style course in a certain topic or certain area, do highlight that, and then we'll be more than happy to organize that.
Yes, if since we still have a few minutes, may I share my screen again and I can show some of these things?
Yes, sure, Dr. Paulina.
All right, let me just get that set up. So this is the Teacher Resource Center that was mentioned, and there's the remote learning resources, teaching concepts with Maple. There's quite there's a lot of material here, and it also talks about how to support use of Maple with our other products and how they connect together. There's different ideas for math curriculum, and ones for engineering as well. So this is a very good resource. Another very good resource is our MapleSoft YouTube channel that people might not know about. We're adding new videos all the time. Let me stop the sound on this. But there are a lot of videos here that have been put in over the years. So for people who prefer watching a demonstration instead of just reading about it, these are very good ones for all subjects that cover teaching, research, learning, and for all our products too. So I would highly recommend you go through and browse those. All right. Are there any other questions or comments? If not, then thank you for listening to my presentation. I also would welcome questions if after this you have questions that your workshop presenters aren't able to answer right away on their own. Feel free to pass the questions to me via Dr. Asim, and I will try to answer them. As I mentioned yesterday, it's late in the evening here, so I'll be going to bed soon, but would be happy to answer any questions I get tomorrow and pass the answers along.
Okay, thank you again, Dr. Paulina Chin. Yes, we have 12 hours difference, if I'm not mistaken. Okay,
That's correct.
It's about 10 p.m. in Canada right now. Okay,
Yes.
so thank you again for very informative sharing. So we will continue the session with the hands-on activities in the Big Data Lab in our college. Okay, UITM. And then I hope all participants today, so we have expanded ideas about developing interactive and impactful content using Maple Math apps. Okay, and for all participants, if you are nearby UITM Shah Alam, come to join our activities here. We have the closing ceremony for International Day of Mathematics today. So please refer to our official Facebook, IDM UITM. And once again, happy International Day of Mathematics. So the tagline for this year is Mathematics for Everyone. Okay, so thank you again, Dr. Paulina, Dr. Asim, and all participants. I can see Mr. Raymond also. Okay, so thank you again
right,
for
thank
your
you.
time. Okay, so give the talk to us. Okay, so I hope we can collaborate again in the future.
Yes,
Okay.
definitely. Thank you.
Okay, thank you so much.
Okay, goodbye.
Goodbye.